All right, seems to be working now. So hopefully that was a one-time deal. All right, so we're going to start Unit 3 today. Unit 3, I haven't quite mapped it out yet, but it will probably take us into second quarter. And so looking at probably that first week in November-ish, maybe the second week in November-ish for a test on that one. So we'll start with it today, and then we'll have a special thing to do. I got it kind of mapped out here. I got to look now. So yeah, we'll start with it today. Tomorrow I've got a non-grading thing that I need you guys to all do, and I'll explain that at the end of class today. And then next week we'll get into some polynomials and all that fun stuff. Okay, so we're talking polynomials this week, or this unit, I should say. But in order to do that today, what we're going to do is we're going to talk about exponents and scientific notation, kind of a refresher in the exponential world, or in the exponent world, I should say. So if I have you remember the fact that x to the fourth power, and that is how that is said. It's not x4. Okay? It's x to the fourth power. Okay? Math in itself is its own language, and part of my mathematical teaching requirements is to teach you how to speaketh math. Okay? And so that is read x to the fourth power. Okay? Now, x to the fourth power means you take x times x times x, and times x again. You take it times itself 4 separate times. Okay? So, with that being said, what I would like you to individually do right now is I would like you to try those 6 problems. Just want to try them. I'll post the answers here in a couple of minutes, see how we are, and then we're going to go over all of that kind of a thing. Okay? So trying these 6 right now. So the answers here would be, I should say, answers here. Come on, come back to me here. Board. Notebook. There we go. Now I can write. All right. So the answers here would be x to the 7th power, 8x to the 6th power, x to the 5th power, x to the 8th power over 9y squared, x to the 12th power, and 1 over x to the 5th power would be the answers there. Okay? Show of hands out of the 6 total. Out of the 6 total, show of hands, those that have cameras on, how many did you get right? Be honest, because frankly, you know, I'm expecting somewhere in the 2 to 3, maybe 4 or 5 range. Okay, good, okay, all right, awesome. Now, that was just a refresher to see, because you've seen these properties before. You saw them in Algebra 1, you saw them in Geometry, you saw them in Algebra 2. Okay, just a refresher to get you back into the groove, thinking of it. Now, let's talk about what those properties of exponents actually are. Okay. So the first property is the product property. Okay, would be the actual name for it. And if you want the actual names of all of these properties, they are located in your textbook. If you just search properties of exponents. Okay? But the kicker here is that we have to have the same base in order to use most of these properties. Okay? So when we have the same base, we can do that. And what we do here in this product property is we add the exponents. Okay? So this actually would end up being a to the m plus n power on that one. Okay? In number 2, when it's a power to a power, okay, that's what it's called. It's a power to a power property. When you have an exponented term and you take that to another exponent, that is when we multiply the exponents. So this would be a to the m times n power. Number 3, or property number 3, is the quotient property. And we utilize that one when we are dividing same base again. That's the kicker. We need to have the same base in order to utilize this. And on this one, we subtract and it's always top minus bottom. So this would be a to the m minus n power. Number 4 is the positive exponent power. We like positive exponents only. We don't like negative exponents. But we might get a negative exponent from number 3 when we go top minus bottom. So we want positive exponents. So this would be, in order to make an exponent be positive, we switch locations with it. So a to the negative m power becomes really 1 over a to the positive m power. On a side note, if I have 1 over b to the negative n power, if my negative exponent is in the denominator of my fraction, then that becomes positive when I move it to the top. Okay? We reciprocate that. Okay? Number 5 tells us that anything to the 0 power is 1. Anything and everything to the 0 power, so the exponent is 0, that term, that part, is just 1. Number 6 isn't so much an actual property as it is just a general rule of thumb, in that there's a couple of things going on here with number 6. Okay? The first thing that's going on is that the exponent only controls what is directly in front of it. Okay? In this particular case, the exponent of m is only controlling the b. The exponent of n is only controlling the c, but the exponent of r is controlling both b to the m power and c to the n power. Okay? So that's the first thing that this one is showing us. The second thing that this one is showing us is kind of an extension of the second property that we had on this slide, the power to a power property, in that we basically distribute that exponent into all of the exponents that it is controlling. So in this case, it would go into both. So this would end up being a times b to the rm power times c to the rn power. It's about what the exponent is actually controlling. Okay? So those are some exponent properties. Now, with that being said, and with the fact that you've seen these before, try these two examples now, and we'll see how we're doing on these. Okay, so try these two now. So this exponent of 3 needs to go into there, and this 2 has an exponent of 1 on it, so it also needs to go into there. So we really have here 2 to the 3rd power, or 3 times 1 power, x to the 3 times 3 power, and y to the 2 times 3 power. Okay? So 2 to the 3rd, 2 times 2 is 4, times 2 more is 8. 3 times 3 is 9. 2 times 3 is 6. I get 8, x to the 9th, y to the 6th power for that one. Thumbs up, we're good. Thumbs to the side, we probably need a little more practice on this one. Thumbs down, we've got some questions. Okay. All right. Couple to the sides. Well, that is one of the more common properties, I think would be the way to say it. We'll utilize that one a lot. So those of you that were thumbs to the side, we'll come back to those two unless you have questions right now for me, and you can type those in the chat or you can unmute yourself. Okay? This is a subtracting type 1. So this is going to be x to the -3 minus -7 power. -3 minus -7 is like -3 plus 7, which is 4. So this is x to the 4th power. I could have also done this one a different way. I could have said to myself, well, both exponents are negative, so I need to move them to the opposite parts. So I would move x to the -7th to the top, and it becomes x to the +7th. I move x to the negative third to the bottom, and it becomes x to the positive third. Now I could again do my subtraction. 7 minus 3 is 4. Or I could simply ask myself, are there more x's on top or more x's on the bottom? And how many more? And the answer is there's 4 more on the top. So there's x to the 4th power there. Okay. The question of the day today, I haven't written it out, but I had it in my brain. What is your favorite sport? We're going to have a sport-related question today. What is your favorite sport today is the question of the day. Okay? Type those into the chat. And while you're doing that, try these 4, please. First one, no extra exponents on the outside, so then I'm going to take my numbers and I'm going to multiply them together. I'm going to take my x parts and I'm going to add the exponents. I'm going to take my y parts and I'm going to add the exponents. 2 times negative 3 is negative 6. 3 plus 2 is 5. Negative 4 plus negative 2 is negative 6. So I get here as an answer negative 6x to the 5th all over y to the 6th because we want positive exponents on everything. This negative 3 exponent needs to go into all 3 spots here. Okay. So that's going to become 4 to the 1 times negative 3 power, m to the negative 2 times negative 3 power, n to the 4 times negative 3 power. That's going to be 4 to the negative 3 power, m to the positive 6th power, n to the negative 12th power. Now, 4 to the negative 3 power can get moved to the bottom, becomes 4 to the positive 3. 4 times 4 is 16, times 4 more is 64. So this would become m to the 6th power over 64 n to the 12th power. There would be my final answer with positive exponents. Good on those? Yeah, okay. Eight can be divided by 4 twice. 12 can be divided by 4 3 times, so that's just 2/3 there. Okay. C to the negative 1 minus 1 power, top minus bottom. d to the 3 minus 4 power, top minus bottom. So that would be 2/3 times c to the negative 3, d to the negative 1 power. Now, how this works out is that 2/3, we start with that 2/3. C to the negative 3, that's going to go on the bottom because then it's positive. D to the negative 1, that's going to go on the bottom because then that's positive. So therefore we get 2 over 3c cubed d for that one. Exponent of 1 there on that number. 3 goes in there, 3 goes in there, but 3 also has to go into that one. Okay? All right, so I've got negative 3 cubed x to the 4 times 3 power. I should say times 1. That way I show all of my work. All over y to the 3 times 3 power. Negative 3 cubed is negative 3 times negative 3, which is positive 9, times negative 3, which is negative 27. That stays on top because it's a negative number. It's not a negative exponent. It's a negative number there. So that can stay on top with the x to the 12th. And that would all be over y to the 9th. Yeah. Scientifical notation. Most of you are familiar with the old scientifical notation based upon the fact of that you've had a science class at some point in time. But scientific notation is done a little bit differently. Okay? So we take it and we break it up into 2 parts. Actually, let me tap the brakes on that before we talk about the 2 parts. True scientific notation has 1 digit left of the decimal point. Okay? True scientific notation only has 1 digit on the left side of the decimal point. Okay? So we need to have it in that form. And then we count zeros. Okay? If I need to move that decimal point to the right, that means I'm going negative on my exponent. If I need to move it to the left, that means we're going positive with our exponent. What I mean by that is if I have 72,000 as my number, okay? My decimal point is right there at the end. So if I need to make that be in scientific notation, then this would be 7.2 times 10 to the 1, 2, 3, 4th power. Because I had to move that decimal point 4 spots to the left. Okay. Now, when we're dealing with scientific notation, we will be multiplying and dividing only in scientific notation. So because of that, you're going to have two parts. The first part is the number part. If you're multiplying, multiply the numbers. If you're dividing, divide the numbers. Okay. Then the second part is going to be the exponent. If you're multiplying, you're going to add the exponents. If you're dividing, you're going to subtract the exponents, top minus bottom. When that's all said and done, then you might have to adjust your answer. Meaning you'll have to get it back into one digit left of the decimal point kind of a thing. Okay? With that being said, let's try a couple. Let's try a multiplication and a division. Okay? So first off, this one is saying 6.8 times 10 to the second power times 3.6 times 10 to the 8th power. Well, the first part of my problem tells me that I deal with the number part first. So I'm going to look at these two numbers here, and I'm going to multiply them. 6.8 times 3.6 gets me 24.48. The second part says I need to deal with the exponents. So that's these two numbers here. And because I'm multiplying, I'm going to add them. 2 plus 8 is 10. Now I'm in that I need to adjust my answer. So this decimal point here needs to come over one more so that I have one digit only in front, which means since I'm going to the left, I need to add 1 to my exponent. So my final answer here is 2.448 times 10 to the 11th power. Dividing, same thing, okay? Except now you're looking here at the numbers. 9.3 divided by 3.1 is 3. Exponents, we look at those because we're dividing, we subtract them. That 16 minus 4 is 12. I don't have any adjustments that I need to do because I only have one decimal or one digit in front of the decimal point. So it's just 3 times 10 to the 12th power. Okay? The other part of this chapter that you'll have to do is that you will have to sometimes write an expression for volume, or write an expression using a formula, and that might include scientific notation, that might include plugging some numbers in or plugging some terms in. Okay? 9 times out of 10, you will be given the formula that we're asking you to use. Okay? In this case, we're looking at the volume of a cylinder. The volume of a cylinder is pi r squared times h, where r is the radius and h is the height. So this is saying here that the radius is 2x and the height is x over 3. And we need to find the volume, an expression for the volume here. So the volume is going to equal pi times my radius. My radius was 2x. That's going to be squared, times my height, which is x over 3. The 2, or excuse me, I got 2 2's here. The exponent of 2 is only controlling what's directly in front of it, which means that it is only controlling those 2 terms right there. So this would become then pi times 2 to the 1 times 2 power times x to the 1 times 2 power times x divided by 3. That's going to be pi times 2 squared. 2 squared is 4 times x squared times x over 3. So in the end, the volume here is 4 pi x cubed all over 3. All of these can be looked at as over 1. And therefore, everything goes on the top. 4 goes on top, pi goes on top. X squared times x becomes x cubed. And then the 3 is remaining by itself on the bottom. Okay? So, what I would like for you to do this weekend is I would like for you to get yourself registered for the NTC dual credit portion of this class. Okay? I would like all of that to be done by Wednesday of next week. Okay? Because Wednesday is the end of the quarter, and actually I think I'm off by a week, but that's right. Yeah, nope, I lied. When the following Wednesday, end of the quarter is Wednesday. I forgot October 28th is the end of the quarter. Okay? So get that stuff done ASAP. Okay? So the better you have, the more opportunities you have for being successful. But what I want you to do this weekend here now is I want you to get registered for dual credit. Okay? This class is dual credit through the tech. You have the opportunity to get NTC credit, or college credit, I should say, that will transfer to most universities and colleges nationwide. Okay? So what I've put on the It's Learning page for this week is for tomorrow, I've put 4 videos, and these videos were produced by the tech. The first video explains what dual credit is and explains how to how beneficial it is for you and how you get free college credits, et cetera, et cetera, et cetera. The second video on there is if you've already taken a dual credit class through NTC here at West, and if you forgot your username and password, it's how to reset that information. Okay? So that's the second video. The third video is if this is your first dual credit class, then you need to watch that video on how to go about making an NTC ID to get it. Everybody needs to have an NTC ID in order to be in the dual credit. But the fourth video down here, this video is the most important one. It tells you how to go about registering, and it walks you through the registration process, where you can pause the video, open up a new window, and do the registration while it's walking you through. Okay? But you have to have an NTC ID in order to get that done. Okay? So I'd like to have that done by the end of the quarter because NTC is asking for me to have it done by the end of October. Okay? It's not a requirement to do. Okay? I'll be upfront with you right now. It's not a requirement for you to do this particular dual credit things. However, enrolling now gives you the opportunity in the spring to get those 3 free college credits. Okay? If you don't enroll now, you don't get that opportunity in the spring. Okay? So you got to kind of enroll now to do that. Enrolling now doesn't mean in the spring that you have to take those credits. You can opt out of those credits, and I don't have to submit your grade to the tech. Okay? So right now, we basically every year I tell all of my kids, everybody enroll now, even if you're going to be a midterm grad or if you're going to be not take the credit in the end or whatever. Just enroll now, get it out of the way. It just gives you the opportunity to make that decision at a later date. Okay? So if everybody could watch those videos and or get enrolled in the class this weekend, that is your only homework this weekend, is to get enrolled in NTC. Okay? With that being said, we'll be back in here on Monday and we'll learn some more about polynomials. Have a good weekend, everyone.